The issue of chemicals in the environment is a story about science, politics, and humanity's relationship with the planet. My name is Chris Hughes, independent scientist, and this is the Chemical Journeys podcast. Join me as we uncover the story of chemicals in the environment through conversations with individuals working in this space. So, let's get started. Hello everyone, and welcome to the Chemical Journeys podcast. Today I'm speaking with Dr Katherine Santizo, who is Programme Manager for the Cefic Long Range Research Initiative, or Cefic-LRI for short. Katherine, thanks for joining me.
Hi Chris, thank you for inviting me. Happy to be here.
No, it's great to have you on the podcast. Having worked with you over the last couple of years, and also myself having had the opportunity to be involved in some Cefic-LRI activities, I'm really excited to be able to speak with you on this podcast and share some of the information about Cefic-LRI with the listeners. So let's get started. Perhaps the best place to start is, what is Cefic-LRI? Perhaps you could tell us a bit about the programme.
Yeah, thank you, Chris. And thank you for spelling out the acronym. I actually was going to start with that. But Cefic-LRI, maybe for those that don't know Cefic, it's the European Chemical Industry Council. And we have this research program, research initiative under that, which was started in 1999. And it was started as a global effort to demonstrate our commitment to responsible care, but also to address the needs of research for decision making. The core of LRI is really to link research to practice and policy to advance our approaches of scientific assessments for the safety of chemicals, and to some extent, more importantly, to improve our understanding of the potential health and environmental risks. So it's fully research focused, and we fund research projects to help build that practice to science and policy, but also to build scientific networks that produce high quality science to inform the decision making. And since it's a global effort, there are actually research programs also in Japan under the Japan Chemical Industry Council Association, and in the US under the American Chemistry Council. So all of the programs, the three regions, coordinate and align for the challenges and needs of the chemical industry.
Oh, that's great. That's a really nice overview. And I think it informs that we use a lot of chemicals in day-to-day life. They deliver a lot of benefits for society, right? But there's also the concern or the question around the safety of the chemicals that we're using for both health and the environment. So it's not a simple challenge to address that question. And the nature of science is such that it's always throwing up new questions and new challenges, and policy continues to evolve, right?
Yeah, I mean, as technology has advanced and changed, right, there's always going to be new questions, maybe new concerns also as societal norms and expectations change. Policy has to address that, both, but also research and industry has to address those changes. And so it's really nice to have this program that is able to add to those conversations to look at the scientific work and evolving methods and things like that. So it's been really interesting to see how all of that comes together under Cefic.
Yeah, and perhaps you could reflect a bit on what's special or different about Cefic-LRI compared with other research programs that are going on around the world.
Yeah, I mean, I guess that's a tough question because I also don't know all the research programs in the world. It is industry funded, but one of the core values of the program is that it is transparent and independent, and that we focus on really robust science to address industry needs. A lot of it is we're addressing very specific questions that industry thinks and agrees that we need some answers to. But then once the project has started, the research team really does have this freedom and independence to steer the project as they seem fit. The results obviously are theirs, so intellectual property stays with the research teams, and we're really just wanting to get answers to questions. So I think it's really nice that you have this kind of industry funds, but at the same time it's hands off. Let's see what the research is going to show, what the team comes up with, and let them approach the question as they seem fit.
Yes, and there's a process kind of around all of that, isn't there? So like an annual cycle and monitoring teams as well. Perhaps you could talk us a little bit around that side of things.
Yeah, so it's an evolving cycle. I started about 2 years ago. The cycles we've thought about changing a little bit to adapt a little bit faster, but in general, what happens is that the experts in the Cefic-LRI program, industry experts, prioritize some questions or research needs. Not only that, but we also then have the scoping meeting that fits into this. They're biennial, so every other year. And so we have the scoping meetings, we have our continual research expert meetings to try and understand what are some of the priorities. After this, we have drafting of the projects, and the drafting is coordinated by ESETOC. Part of the use of ESETOC is that we really, like I mentioned, want to make sure that it's maintained transparent and open. And so we have experts convene to help draft the research projects. Then the selection committees or the project costs go out once they've been approved. And then during the call process, we were forming selection committees that are also coordinated by ESETOC, again, to maintain this transparency and independence. Then the selection committees make the recommendations, and we sent out the award letters and try to get started with the project as soon as possible.
Yeah, and then during the course of the project as well, there's oversight, but there's a monitoring team which is made up of stakeholders from various backgrounds.
Yeah, I mean, so part of, trying to link that science to practice and policy is that you want to have tripartite involvement. And so in the selection process, we have experts that then join the monitoring team, but then we also make calls to experts so that they can join the monitoring team to, as much as possible, have that tripartite involvement in the process. Part of the reason to do that is that we know that having involvement early on really builds that trust, but engagement and confidence in whatever the process or the results are.
Mm-hmm, mm-hmm. Yeah, and certainly from where I've been standing, Cefic-LRI has been really an important program for moving things forward in terms of developing tools and developing approaches that address this evolution of science and policy around chemical safety. I can remember my first engagement with Cefic-LRI was when I was working at Shell, and I supported the development of an RFP for addressing water solubility testing for difficult test chemicals. I think that eventually became the Eco 38 project. But the result of that was a really nice technical guide publication to enable people to carry out those tests and get more accurate data on water solubility, for instance. And water solubility is such a fundamental parameter for chemicals, and you wouldn't think this would be a problem, but when you get to things that are very poorly soluble or volatile or oily, you can have all kinds of challenges with that, and we need good data even in those fundamental areas to begin to extrapolate from that to understand how chemicals behave in the environment. So that was a really nice experience to be involved with that. And there's countless other tools and things as well, right, that are being developed.
Yeah, glad to hear that experience. I was trying to remember Eco 38, but that's been quite a bit before my time. Like I mentioned, we really try to focus on how to improve the safety assessment of chemicals, right? That means a broad range of chemicals. Obviously, Cefic has the full value chain involved in it. So we also understand the difficulties that might come for very specific chemistries. And then being able to improve tools for those chemistries, I think it just overall helps and improves assessments. So we have over 25 tools that have been developed through the course of the 25 years of the program. And I think over 10 or about a dozen OECD test guidelines and countless guidance documents, frameworks as well that are developed based on the research projects. And we hope that all of these at the end are put together to really help inform decision making or to just help the assessment process at the end of the day of the chemical.
Yeah, I think that really speaks to a need that Cefic-LRI is fulfilling. And from experience working in more academic areas, they don't always have that regulatory framing on how they're doing their research. And often they're puzzled by some of the problems that we're actually grappling with, like why do you want to assess the biodegradation of a chemical that naturally volatilizes from water? It's like, well, we have to we have to measure a half-life for a persistence assessment, for example. And yeah, these are some of the things that the regulatory frameworks channel us into in the work we're doing.
Yeah, I mean, it's been surprising to hear some of that as well from academia. I mean, obviously, we all kind of start there, but some of the things that I heard in my meeting of people introducing myself as the program manager and just asking for people's experience on the program, one of the things that I've heard quite often is that it's has served as a training kind of platform as well for academics to understand a little bit better the regulatory process and what are the questions that are needed to be addressed. And it's not always considered or maybe part of the discussions when you're looking just on plain research. And so it's been really nice to also hear the added experience and added value that academics have had in
Yes.
being part of the program.
Yes. Yeah, that's a really good point. I think whilst it can be quite technical, the regulatory space, and complex, and you're very unlikely to learn about it or gain a great understanding of the nuances of it unless you immerse yourself within it. And most people don't have the time to do that in their day-to-day work. So yeah, this seems like a great opportunity to upskill.
Yeah, exactly.
Good. You mentioned there about most of us starting out in academia, and perhaps that's a good prompt for us to talk a little bit more about your own background and how did you start out? What were your research interests, and what was your journey to becoming program manager at Cefic-LRI?
Yeah, it's always an interesting question for me how I ended up where I end up. But it's most of my philosophy is taking opportunities wherever they come. But I actually obtained my bachelor's in chemical engineering and also not in Europe. I'm originally from Los Angeles, California. And so I did my bachelor's in the University of California system at Santa Barbara. And most of my time there, I mean, I've always been very interested in research, wanting to know how things work, how things are made, and things like that. And I think that's why I gravitated towards chemical engineering because I was also really interested in the chemistry of things. And so while I was at UCSB, since the beginning, actually, before I even started, I joined a research team working on nanomaterials. Throughout most of my bachelor's, I actually did work under the Center for Environmental Implications of Nanotechnology, which is a UC center focused on a broad range of topics dealing with nanomaterials and the environment. I dipped my toes, as I would like to say, on ecotoxicology there, but also had my traditional training, of chemical engineering and processes of chemicals. I always had this interest in kind of both worlds. After my bachelor's, I decided to work as a material analyst for a small company in Pasadena, California called Materia Inc. There, it was really interesting because I learned a lot about the product development phase, but also how to analyze the materials, not just for their physical properties, but also, I was always interested in a little bit more. And so after working there, I decided that I should go back to school and get my PhD. I moved across the country from California to Virginia to attend Virginia Tech. There I was in the program of Environmental and Water Resources Engineering in the Department of Civil Engineering. There I really wanted to bring together my knowledge of chemistry and the processes which chemicals and products are made and the environment. I was looking at groundwater contaminants in the surface water groundwater interface, also known as the hyperoic zone. I was very interested to understand the conditions that led to chemical transformations in this unique environment. And so it really allowed me to use my understanding of chemistry, but also learn about how those chemicals move in the environment. So looking at the fate and transport of them. And so I did that. And then while I was doing my PhD, I actually got the opportunity through a grant to go to Germany. There I was selected to work at BASF and kind of went back to my beginnings of nanomaterials. We were looking at release of nano release in food contact materials, which then ended up in me getting a postdoc position at BASF working on microplastics. And actually, it was this work in microplastics that had introduced me to LRI because I was doing LRI projects, amongst other things, at BASF. And so I was introduced to the program. And when I learned that they were looking for a new program manager, I thought this could be an interesting opportunity to also have a better understanding on the broader scale. How is it that what questions are we asking as an industry? What are the needs? But also, how can we, I was very much interested on how can we better communicate some of the science and strategize on the long range part. That's a part that actually really intrigued me, since it's a long range research initiative, thinking about what is to come and how can we support and help and address any of the challenges was really intriguing.
Yeah, it sounds like you've had a really varied journey, which I'm sure is standing you in good stead for the work you're doing at the Cefic-LRI, in particular the work around microplastics and also contaminant transport and transformation in the environment.
Yeah, indeed. And, we do quite a bit of human health work as well in the program, right? It's both human and environment.
Mm.
So I did do a bits of human health toxicity work at BASF. So then this has just really catapulted my learnings, which, I'm a strong believer. And I think some other of your guests on the podcast have mentioned the interdisciplinary work. So I thought that this was really a good opportunity to understand maybe some of the commonalities between the two disciplines and how can we progress some of that more holistic understanding that we're seeing a lot more questions from.
Yeah, absolutely. I think that is becoming more and more the big challenge of the day, integrating the environment with human health, and especially when it comes to people's exposure to chemicals via the environment, but also combining or when you get down to the deep biological level, as we explore some of the mechanisms of toxicity, there really is not a great deal of difference between organisms in the environment and humans in many instances.
Yeah, exactly. I always say I'm not necessarily an expert at one thing because, as you rightfully pointed out, my journey has been quite varying. And so, kind of, when you start feeling like you might get to an expert, I've decided to jump to another thing. But it's been quite interesting to just the learning process. But what you do hear a lot is that the mechanisms, right, at the molecular level, the mechanism that leads to toxicity can be quite similar, especially when you look at the genes, where at the end of the day, humans are animals. And so there's a lot of overlap, and trying to understand this overlap and how does it then inform toxicity or health or effects can be quite crucial to integrating these two disciplines.
Mm, mm. Yeah, and I imagine that there's a whole feast of knowledge sitting within both disciplines from decades of research that it would be really useful to try to bring together to support our broader understanding of chemical safety. Is there any work you can highlight from LRI that's sort of looking in that kind of a space?
We're starting to think about that, and actually brings quite well to the workshop we recently had in June, where we
Mm.
had an interactive session on One Health and what does One Health mean in the context of chemical safety. And we had a few presentations from Amelie Otts from the International Collaboration for Cosmetic Safety, from Leonie at Alter Talks, and Paul Thomas from Curatis, who I think has already joined you. So he presented something that was more on the practical sense and just showing the tools that can be created to look at these key initiating events to an adverse effect, right? Or an adverse outcome. And so it was really interesting to see some of his work on how, yeah, at the end of the day, we're using different terms, but we're kind of meaning the same thing. So if we put that aside for a moment and look at that one specific part, then we can start learning about how to integrate it in both disciplines. And some of the participants then, when we had the discussions, we're also talking about how, in the environmental space, we know a lot about the transport of chemicals.
Mm.
And then how can we use our understanding of this transport, especially if you think about a little bit maybe fluid dynamics, right? Our bodies are mostly water. So can we take some of these understandings on transport and then bring them to the human side, and vice versa? On the human side, there's been a lot of work on endocrine disruption can we learn something from this endocrine disruption work that has been done on the human health to bring it into the environment? And so these were kind of some of the initial discussions that we had
Mm.
at the workshop that I think, I hope that we can continue those discussions and maybe develop some nice projects out of.
Yeah, no, that sounds like a rich vein of new scientific inquiry that I'm sure that Cefic-LRI will be mining in the future. So that's great. What about other recent activities? So you had the workshop in 2025. There was also the 25-year anniversary, which was in November last year, which I was able to attend, and that was a really an excellent event and a great celebration of the program. Anything else that you want to highlight?
On events or activities, you mentioned the 25th year anniversary. Quite honestly, it felt like such a privilege to be able to be the one to commemorate this milestone,
Mm.
especially since I had just started. And, there is quite a bit of rich history in the program. We have such a wide, varied number of projects, and just trying to bring the community that has contributed to the success of the program was really nice. I think one of the things that also was really nice was that the celebration took place at the Solvay Mansion, right? So just the historical meaning of the venue that we were in and the commemoration of the program. But I think more than anything was the people that we were able to bring back together to commemorate this milestone was really nice. And to communicate on it, I think sometimes as scientists, we get so involved with our work that we forget that we need to also tell the world what we're doing and what it means and what it adds to our society. And so it was really nice to do that because it wasn't so technical. It was more really a celebration, which we don't always get to do as scientists.
Absolutely. And there was a nice program book produced as part of that, which really brought together all the kind of accomplishments and the great science and the people who'd received awards over the many years as part of the program. So, yeah, we'll be sure to put a link to that document in the show notes for this podcast because it provides a really nice consolidated picture that's easy for even a layperson to read and digest. And I think also Marco Mensink attended, Secretary General of Cefic, Ilham Kadri as well, the CEO of Science Co, which I think showed how important this program is seen to the chemicals industry as well.
Yeah, I mean, I think it was really nice to have both of them there. And I think, if you remember their message was really on this communication piece, right? On
Yeah.
we have to show the world what we do. And obviously, Science Co. being part of the Solvay family, Ilham Kadri was able to also, kind of delve into the longevity of things, right? Solvay it's a very long-standing company with much success. And so it's really nice to also hear from her and of course Marco, who knows the program, and his, I guess, plea to some extent to communicate and to really showcase what is that we're doing. And actually, he was really a big supporter of this book that you mentioned, the LRI anniversary book, which was an exercise on communication for me because, you know, usually we're producing technical work, right? We have publications and reports, but the book was really the intention was that anyone could pick it up and understand what the program is, what the vision is, what the mission is, and what has been the outcome. I'll have to shout out here Begum, who is my colleague, communications colleague, because it was a lot of back and forth on actually this word, people don't know what it is. We're so
Mm-hmm.
used to it, but actually, no, we need to find another way to describe this and to inform on this. So at the end, I think what was produced was a book that hopefully anyone can pick up and read and also have really nice illustrations of what is it that we're doing with the program.
Yeah, no, it's really, really great. I really recommend people take a look at that. Yeah, and then of course you've got your project calls for this year, which have closed now, but they'll be announced soon, I presume.
Yeah, so we had calls, like you pointed out, that closed in June. We had 3 project calls this cycle looking at quantitative uncertainty of traditional versus next generation risk assessment, on mobility of chemicals, and furthering the work on the OECD TG 309 for difficult to test substances. And so we are actually at the point as we speak of finishing the selection. The selection committees have been hard at work over the summer to try and come to an agreement and recommend one of the proposals from each of the projects. And so we hope that we can send word letters soon in September, hopefully, so that we can get started on those projects before the end of the year. And maybe here I can point out that along with, well, those ideas actually really stemmed from the scoping meeting that I've mentioned earlier that we had in 2024, so yeah, last September. And we co-hosted that event with ESETalk to get people to bring ideas to both ESETalk and Cefic-LRI. These three ideas actually came from that. And so it was really nice to see the full process, at least for me for the first time, to see the ideation, the discussions, the final piece of the call, and now the applications. We received some really interesting applications and approaches. I'm just looking forward to get that work started.
Yeah, it's great to hear the process that led to the announcement of these calls and the launch of these projects. Certainly looking at the list, I think they're all really important scientific topics to be diving into. On the NAMS case, there's a lot of discussion now, and rightly has been for many years, a drive to reduce animal testing, and a lot of that has been a bit of a logjam there, not only for the development of these alternative methods, but also understanding how they compare to animal based methods. And of course, all methods, all tests have their domains of applicability and their uncertainties, and uncertainty is something that we really grapple with all the time as scientists, and especially when it comes to regulatory decision making. There's a lot of value judgment that goes into that as well. And then in the case of mobility, I've seen that now all of a sudden we're all talking about mobility of chemicals in the environment, and that's created a huge challenge because until recently that wasn't the biggest priority for industrial chemicals. It hasn't been quite a focus chemical by chemical as some of the other properties, and while you can get a reasonable judgment of a chemical's mobility if it's a neutral organic compound, you encounter huge challenges when it comes to chemicals that are charged or ionizable. A lot of the historical test methods that we have available for screening these properties aren't applicable to these kinds of chemicals. So again, I think this is a really big need as well, because to run sort of more high-tiered testing of these properties for all chemicals would be an enormous cost that would hit the industry at what is a really difficult time, and would take a very long time to actually run the tests as well, just by the nature of testing capacity across Europe. So all of these policy developments, they really do have consequences that ripple out through the industry.
Yeah, and I mean, at the end of the day, it's also right thinking about the protection goal. And so when you're talking about uncertainty analysis, mobility, and assessments, if you're testing a substance like the ionizables on a method that really isn't suitable, are you really meeting that goal? And so while it is, it's I think it's two-pronged, right? You have the discussion of, yes, these tests are time consuming, are cost heavy, resource intensive, and at the end of the day the decisions hold a lot of impact on the industry. Is it really then meeting the goal, the protection goal that we have as a society, or regulatory or whatnot? And so I think it's thinking about these questions both on the regulatory space, but then also asking at the end of the day, are we doing what we intended to do? And so I think, with some of these projects, like you mentioned, now with the mobility, it really is focused on ionizables, to try and understand a little bit better what parameters really are crucial for that assessment. And then on the uncertainty analysis, I think part of it is also the protection, but the other part is the change aspects. We get very used to our methods, our assessments, our way of doing. And so it's really to address all of that in some shape, way, or form.
So I really look forward to seeing how these projects play out and contribute to the overall discourse on chemical safety in the years ahead. I'd like to get your perspective on any other key research areas or needs that you want to highlight before we wrap up our conversation.
Yeah, I think, like I mentioned, because I'm thinking both the environmental and human health part, maybe if I split a little bit on each one, some of the discussions and needs that we're seeing. And I think here part of my role is really to also understand what's happening in the regulatory landscape and policy landscape, but also what are some of the questions society has, and bringing this all together to start to inform. So we look at what the commission's putting out, what research organizations or research institutes, what ECHA's key areas of regulatory challenges look like, to really start framing our discussions. But something that I think continues, and I don't know if it will ever change, is on the topic of persistency for the environment. And you are quite an expert on that topic, but also then exposure science, right? So what opportunities are available to reconsider exposure, and now also thinking about this next generation risk assessment, how can we better integrate exposure into this? And so those are some of the discussions that we're having. Of course, when you're looking at very specific chemistries or substances, we're looking a lot at polymers, and the interest around polymers for REACH. Of course, microplastics, plastic-associated chemicals or additives, which obviously continue to be very important topics, especially for society. PFAS, which I think falls under all of the buckets: persistency, mobility, exposure, etc. So yeah, it's really going to be interesting to see where we can get ourselves involved. In terms of human health, the NAM discussion is quite important here too. So the next generation risk assessment piece of things, how to develop the NAMs, but I think also how to build regulatory confidence and acceptance on the methods that are available. So what validation needs to happen? How can we improve the time for acceptance and uptake, as that's one of the big areas that I think a lot of experts always, maybe rightfully so, indicates. But we're also seeing a lot of development still in the endocrine space. So for non-AIDS modalities, so not your typical estrogen, androgen, thyroid, and sterogenicities modalities. So looking maybe further on some of those other pathways that can disrupt the endocrine system. Linked to some of that non-AIDS that we're seeing is this cardiotoxicity and immunotoxicity. So how does some of these chemicals influence heart diseases and also immune responses, right? So we're seeing a lot of garnering of importance, but also attention on these topics. I think more broadly so, we're having a lot of discussions around circular economy, because this could have a big influence and impact on how we think about traditional risk assessment. If we're thinking about circularity, you're reintroducing chemicals into the system. How does then that change how you assess them? Do you evaluate the recycled materials? Do you not? What technical challenges do you have? And so I think that this is going to be something that is of importance to industry, but really challenging to try and understand and know where to start on this one.
No, absolutely. There's so many topic areas, right, that need to be addressed. I think that you're definitely right in highlighting exposure. Exposure connects so many of these big challenges. You mentioned the circular economy. I recently had Thomas Hartung on the podcast, who has been pushing hard on the initiative to develop the Human Exposome project, because he sees that as how we're going to continue to be able to make gains overall, ultimately, which is the goal. Gains in improving people's health is to truly understand exposures to a better degree, not only chemicals but other factors as well, such as their lifestyle, geography, demographics, etc. And he really sees that artificial intelligence and machine learning, the advent of these tools, will be a step change in helping to deliver some of the gains in that area. I'm really glad you also brought up the topic of persistence, and I'm certainly seeing how that issue is really exploding. If I think about 10 years ago, you'd be amazed probably to think that this wasn't really a big issue. People weren't really talking about persistence. It was hard to get them excited about it. I think there would be one small session at CTAC, and then look at where we are now. I think that really shows how quickly things can develop and change and be triggered by certain key issues like PFAS, like microplastics. Has got people thinking about the long-term fate of chemicals in the environment, and this really connects to the issue of exposure ultimately as well. And I can highlight that Cefic-LRI has played a really important role in some of the developments in persistence. I was lucky to work on the Eco52 project, which sought to address a lot of the challenges that were being found in our standard persistence assessment frameworks, like issues with substances that had challenging properties, substances that had a complex composition, but also issues around how to do the weight of evidence process. What role does modelling have in understanding the persistence of chemicals in the environment, and also having a view to polymers, which were really coming down the tracks as a new challenge that will need to be addressed in terms of persistence. And off the back of those projects, they then led on to the development of a new tool, the persistence assessment tool, which was co-funded by Carway and the ICCS. Cefic-LRI and ESITOC also supported the development of that tool. So it's a really nice kind of consolidation of knowledge that's been developed through the LRI program, and I'm pleased to say that the publication for that tool has been accepted in Integrated Environmental Assessment and Management, and so I'm hoping to be able to announce the publication of that paper very soon. But people can still access the tool and the preprint, and I'll put those things in the show notes as well. And those are just a couple of things that are linked to persistence. There are also projects related to the OECD 309 test guideline, as you've said, which have led to the test guideline being added to the programme for revision at OECD. And also a new project, Eco64, which is looking specifically at soluble polymers. How do we assess these soluble polymers? How do they behave in standard tests? And in particular, how do the results in screening tests compare with the results of simulation tests? Because we're faced with the challenge of assessing the persistence of these materials, which again weren't in the focus just a few years ago. And so we have to play catch up. The science almost has to catch up with policy in terms of determining whether the tools we have are really fit for purpose.
Yeah, no, exactly. And I like that you mentioned the role with persistency, because part of the goal with the program is that we can see that we have that foresight and start putting in some funding into this type of work that we know has a likelihood to then come at us like persistency did, and I think outside of Eco 52, 55, 64, and the PAT that you've already mentioned, there have been quite a bit of projects in the catalog that had tried to also look at persistence. And so it's all kind of like a building portfolio of information and resource that then can be used to hopefully help inform that decision making, right? And it's not just persistency, but so many other topic areas. And I think, kind of going back to what you mentioned with Thomas, I think that the use of AI and machine learning and just the advancements that we're having with these models to some extent means that that time frame is getting shorter, right? Because now we have all of these tools at our disposal that can get us information more effective and more efficient, which means that what takes maybe a decade to reach kind of critical attention might happen faster. And so it's how then we also then utilize these tools to help us with information gathering and evaluation of the data.
Mm-hmm. Yeah, no, exactly. So it's a really, really exciting time. And I really appreciate the opportunity to speak with you today, Katherine, and congratulations on what you've achieved so far and what you continue to do at the helm of this programme, because it really is important stuff. So just before we finish, I generally ask my guests a couple of questions, if you don't mind. So first of all, what is one big goal that you're working towards in the months ahead?
Oh, in the months ahead, that's a big one. Generally, I think one of the biggest aspects that we're working on with the program on a broader level is our communication of the program, but also how to more effectively do that science communication. Like I mentioned, that for me is quite important on a personal level, and I think it really hopefully can contribute to the perception and trust of the public on the science that we're doing and funding at LRI. So I'll say that.
No, I mean, that's a big goal and an important one as well. And the other one is, what is one piece of advice you'd give to somebody, either yourself or somebody else who's starting out in their career?
I think my career says it to some extent on just taking a chance. When an opportunity comes knocking, if it's interesting, to not be afraid to throw yourself in there. I don't think I would be where I am without that.
Yeah, and that's great advice. I noticed you said that earlier on in the podcast, and certainly I think that your career sounds like one of those that has meandered through various areas, and you could never plan it. but you're probably quite happy with how it's evolved. And I think that more and more for young people, that is how their careers are going to evolve. Nobody has a kind of linear career anymore. So yeah, that's really great advice for people. Yeah. All right. Well, Katherine, thanks very much again. That's been really fantastic. And thanks to everybody else who's been listening. Your time's really precious, and so I'm really grateful that you've spent it with us. If you've enjoyed this podcast, please tell your friends and colleagues, like and subscribe if you can, and spread the word about Chemical Journeys. Thanks very much, Katherine.
Thank you, Chris.